Thank you for coming out to this session. I'm going to be talking a bit about identity, security, authentication, and JSON Web Tokens today. Who of you has ever used or heard of JSON Web Tokens before? Almost all of you. Now keep them up. Who knows how they actually work? That's a few more people except my colleague here and a few scattered across the audience. Cool, so I'm going to be talking about authentication, token-based authentication, and JSON Web Tokens today. And hopefully you can learn a thing or two. If not, still, thank you for coming out. But let me quickly introduce myself. My name is Sam Bellen. I'm from Belgium, which is not that far from here. And I'm a developer evangelist at Auth0. If you've never heard of Auth0, really quickly, we're an identity as a service provider, which means that we try to make it as easy as possible for you to implement a secure authentication flow so you can focus on building your actual products, because that's what you want to do, right? You want to build your own actual products. I'm also a Google developer expert, which means that somebody at Google once said that I know something about something. And I organize a few meetups, one in Belgium and an identity and security meetup in London. So if you're ever in Belgium or in London, feel free to join. If you want to follow me on the internet, Sambego is my username in almost every website on the internet. So please do. Then on to the most important slide. I have cat pictures, cat stickers. So if you want a cat sticker, send me a picture of your cat, your dog, your bunny rabbit through Twitter, and I'll give you some stickers after this talk. Okay. So, this is what we're going to be looking at today. We're going to see a bit about traditional authentication, or at least what I think is traditional authentication on the web. We're going to see what a token is. We're going to look at token-based authentication. And if we still have some time, we're going to look at the future of authentication. All right, traditional authentication. What I mean with this is, you have the typical scenario, a user, a browser, and a web server. And with traditional web applications, all the logic gets handled by the backend on the server. This can be one server, multiple servers, but it's usually a server-generated page that gets served back to the browser. So the user does a request in the browser to get a certain web page. The web server is doing all the heavy lifting, and it sends you back an HTML page. But if you want to access a protected resource, you're going to first send your credentials, username, password, through the browser to the server. And if they match, if the server decides that these credentials are still valid, you get back your web page and the browser renders this. This is familiar to everybody in this audience? I think so. But it does not only send you back the HTML, it's often going to send back a session cookie, just so the next time you want to access something protected, you don't have to log in again, because that's annoying. So the next time you want to access something protected, you send along this cookie, and if the session and this cookie is still valid, the server will be like, fine, you can access this protected resource, and it's going to send you back the web page that you want to render in the browser. But there's a few problems or differences between traditional web apps, like the one we see now, and single-page applications. The first one, a traditional architecture, is usually the browser and one server, which is all the logic, the creation of the HTML and stuff. This can be a whole bunch of service, but this is usually one backend service. A single-page architecture can look something like this. You have your single-page application running in a certain domain, and then you have a bunch of APIs that you want to consume. Maybe an authorization server, a general API, a payments API, some external APIs. They all have different domains. So this can create some problems. You can also have a multi-architecture, something like a mobile app, a desktop app, and a web app, and they all consume the same data, the same API. Who's working on a product that has more than one client at the moment? A lot of people, right? And isn't it funny that only the web uses a cookie to remember the session, while a mobile app or a desktop app doesn't use cookies, because a cookie is inherently something of the web? So it would be nice if we could authenticate many sessions the same way we do across all of these clients. Some of the problems with traditional cookie-based approach. Cookies don't like cores. Who likes cores? Usually there's one person who's like, yeah, I like it, but nobody likes cores. If you have a cores problem, which we all had at least once in our careers, you go to Google, you type in, I have a cores problem, you end up with Stack Overflow, and you just copy-paste whatever is written on Stack Overflow, because nobody likes cores. Neither do cookies. Cookies require state, because usually inside of this session cookie is a session which you'll save in a database together with an expiry date and maybe some other attributes, so that's states. When we work with modern APIs, we try to make them as stateless as possible. So it would be nice if we don't have to require this state to be kept on the back end, if possible. And cookies don't flow. You cannot send a cookie which is issued by a certain domain to another domain just because cookies are tied to a certain domain. You can have some workarounds, but most, let's say that they are tied to a domain. So what's the solution? Maybe it's token-based authentication. I think so. We'll see what this is later in this talk, but first we have to look at what a token is. And to me, a token is a unique identifier that represents something, either an identity, some access management, credentials, whatever you want. It's something that represents something, and it's usually, or it's always, unique. You have a few different kinds of tokens. An access token, we've used this before. A few people, okay. An ID token, same question. A few less people. A refresh token, still some people. I'm going to explain what these are later. This is just a poll to see who knows of who has heard or used these tokens. And they're often an opaque string in the form of a UUID, which means they don't contain any information. They're just a random, unique string, which you have saved in your database or in your backend someplace. And based on this database entry, you can get some more attributes like expiry date and what have you. But they don't have to be. They can be XML. If you're using SAML, a token, and a SAML token is XML. And they can be JSON Web Tokens, which is what I want to be talking about today. A JSON Web Token. So the name says it all. It's JSON and it's a token. And at Auth0, we use JSON Web Tokens as much as possible, just because they're cool and we like them. And this is a JSON Web Token. And as you can see, they consist out of 3 different parts, 3 different colors with a dot in the middle. Who's ever noticed that the JSON Web Token consists out of 3 different parts? A few people. Nice. Good. So there's 3 different parts, and they all have a different purpose in this token. And the first one is the header. And what the header is basically just a base64 encoded JSON object. If you would decode this, you would get something like this, which tells you the type. I'm a JSON Web Token, and I have been signed by this algorithm, HS256 in this instance. So it tells you what it is and how you can verify the signature of the JSON Web Token. The second part is the payload, and this is usually the biggest part of a JSON Web Token. Again, just base64 encoded JSON. If you decode this, you can get something like this. And it usually contains a lot of information that is useful for you, the person or the API, the client that consumes this token. It can contain the subject, your user ID, your family name or given name or username, when it's issued at, a timestamp, but also when it expires. And this is something really interesting. A JSON token can contain the date that it expires. So no need to save it somewhere in a backend in a database with an expiry date. It's already inside of the token, or it can be if you want to. And you have a bunch of different claims. The first one are reserved claims, and these are basically just the claims. A claim is a key value pair in your JSON. These are the claims that are being specified by the spec. Something like subject or issuer or issued at or expiry date. These are all claims that have been specified in the spec of the JSON Web Token. The second one are public claims. And these are claims that are used often with a lot of APIs, but are not really specified by the specification. But they are standardized in a certain way. There's this website by IANA, which has a whole list of claims which are used often. Can you read this at the back, more or less? And you see things like given name and family name and nickname. And these are claims that you see a lot on websites, but you might call it first name or last name instead of given name and family name. And just for API interoperability, IANA decided to standardize a whole list of claims so that most APIs can be more or less the same. And lastly, we have some private claims. And this is basically any claim you want to put inside of your JSON Web Token. Do keep in mind that it's just base64 encoded JSON, so don't put a credit card or something in there, because everybody can decode base64. But as long as it's valid JSON, put it in there if you think it's necessary. If not, keep it away. The last part is the signature. And basically, what this is you take a signing function. This one, for example, you take your header, base64 of that, base64 of your payload, and then run it through this function together with a secret in case of this algorithm. And what this is it creates a signature based on the content of your JSON Web Token. Would you change something in the header or in the payload, this signature will not match, since you passed along both the header and the payload to this function, and their signature is based on the content of that JSON Web Token. This means that JSON Web Tokens can be verified. You can verify that a JSON Web Token has not been tampered with or the content, as long as you know the secret in case of this algorithm. We also have public key and private key algorithms, which we'll see later. But you can always verify that the content is not been tampered with. And this is something, your super secret key, usually is random, doesn't really matter. But it's always, this algorithm runs with a secret key that both you, the person who needs to create the JWT, and the person who wants to verify needs to know. So if we take some JSON like this, we take a base64, and run it through a signing function, we get a JSON Web Token. This is our header, our payload, and our signature. Now if you would copy this and go to jwt.io and paste it in here, you would see that the JSON that we had on the right is exactly the one that we had on the slides previously. My name, there's a space missing because I made a bug. I see now, but it's more or less a JSON that we just decoded or encoded previously. This JSON, my header and my payload together with a signature. Some real world examples, because talking about tokens, it's a bit abstract. You want to see what a token really is. So an access token, for those of you who've already used an access token, it can look something like this in the form of a JSON Web Token. It contains the issuer who has issued this token, your authorization server, the subject for which user is this token intended, the audience, which APIs can consume this token, the issue that date, expiry date, some scopes if you work with scopes in OAuth. So a lot of information about this access token is already stored inside of the token, instead of you taking this UUID of this access token and finding all the information later in the database. The same thing goes for an ID token. And an ID token usually contains a lot of information about the identity of the person who authenticated. And this can be something like a nickname or a name or your profile picture. And again, the expiry date, issue date, and stuff like this. So if you take it, and if you take these practical examples, an access token like this contains some information about accessing an API, and an ID token contains some information about the identity of the person that has authenticated. You can use JSON Web Tokens in a really practical way because they contain all of the information you want to know. If you want to do this in JavaScript, you might do it like this, but usually you're going to use a library for this, so it doesn't really matter. Now, we've seen the signature created by a mutual secret, a symmetrical algorithm. Of course, there's also asymmetrical ones, which use a private key and a public key to sign and a public key to verify the signature. And these are a bunch of algorithms that are supported in the JSON Web Token spec. But if you do this, you want to share your public key so people can verify the signature. And there's a way with that to do this as well. It's called a JSON Web Key. Looks a bit like this. Again, it's some JSON which contains some public key information which you can use to verify the signature of JSON Web Tokens you want to verify. You can share them in a whole bunch of different ways, but if you use the OIDC spec, there's often a .well-known /OpenID configuration route configured in your authorization server, which looks something like this. And it contains a bunch of information about your authorization server. And one of the things it contains is your JWTS URI, which is another URL or URI you can click on, and they contain some information of your public keys. In this instance, it's just one key. This can be multiple keys if you want to. But this is all public knowledge. Everybody can get to your public key because you can only verify with this key. You cannot sign with a public key. You need a private key for that. So it's often JWTS.JSON in your well-known route. So JW token, JSON Web Key. There's also JSON Web Signature, which is basically the bottom part of your JSON Web Token. It's a signature in the form of JSON. There's also JSON Web Encryption if you want to encrypt something. And sometimes people encrypt their JSON Web Tokens just so nobody can look inside of the payload and the header. I'm not going to be talking about JSON Web Encryption too much because it's very complicated and I will be standing here for another hour. But it's possible. There's this standard JSON Web Encryption which lets you encrypt JSON on the web. So let's make a little comparison. On the right, we have a passport of Belgium in 4 languages because we like to be, we like to make it difficult. But what it says is, I am a passport by the Kingdom of Belgium from the European Union. And it's more or less the same than the header of a payload or the header of a JSON Web Token. It says, I'm a JSON Web Token, and I've been signed with this algorithm. So it gives you some metadata about the token or some metadata about the password. Now, if you open this passport, you'll see some information about myself, my name, my surname, my nationality, my expiry date of the passport. And that's also something more or less the same like the payload of a JSON Web Token. It contains all the information you think is needed to access something, either identity information or information to access in an API. And of course, every passport has some features to verify that it's a valid passport that's not been forged, like some UV hologrammy thingies. And a JSON Web Token also has a signature, so you can verify that it's a valid JSON Web Token. So, in essence, a JSON Web Token can be looked at as a passport, either to get some identity information for somebody in an ID token, or to get access to an API as an access token. So let's see it in action. I have this wonderful website, and what it does is it has two buttons. One shows me dog pictures, because we all love dogs, and one has a button that shows me cat pictures. But if I click on it, it asks me, oops, no authorization was found, because if you know dogs and you know cats, cats are always a bit more difficult than dogs, right? So what it needs me to do is I need to log in and get some credentials to access these cat pictures. So I'll log in, and this is taking me to Auth0. Just log in with Google for simplicity. Use my email. And now we're logged in. And the first thing you can notice is right away we have my username and my image in the right-hand corner, just because I got an ID token back with that information about my identity. So I can use this ID token and show the information as soon as I get it. No need to do an extra request to user info endpoint. It's already in this ID token. But I also got an access token back. So if I want to see a cat picture now, I can see cat pictures. Yay! This is my cat, by the way. I'm very proud of her. But by just authenticating and getting back an ID token and an access token, we are having a protected API resource, this cat pictures API endpoint that we can use. So if you would look at it from an API perspective, you have 3 endpoints. Let's see if I can enlarge this. This is the biggest I can do. So we have one in which we send the username and password. Don't send this as a password in real life. But what it does is it gives you back a JSON Web Token. It has a second API endpoint to get dog pictures, which give you a random dog pictures. And then it has a third one to get cat pictures. But as we've seen, without a valid access token, we get the error, no authorization token was found. So we'll have to add it as a bearer token. Paste in the token we just got by authenticating. And if we do so, we get an error. But if we copy it correctly, we have access to our cat pictures. But by copying the wrong token, we saw already one of the features of a JSON Web Token. If it's not a valid JSON Web Token or it is malformed, your middleware will tell you about this and it will not accept this JSON Web Token. The same thing goes for a web token, JSON Web Token that has expired. So the expiry date inside of this token is somewhere in the past. So if I try to use this, again, same mistake. It tells me this JSON Web Token has expired. No need to do some extra checkups or lookups in the backend. This token's expiry date has been in the past, so it will not accept this token anymore. Even though it might be valid for all the other claims, the expiry date is in the past, so it's not a valid token anymore. The same thing goes for a token where you try to tamper with. So you change something in the payload, and the payload and header do not match the signature you created. So if you use a token like this, it will tell you straight away the signature is invalid. So without doing extra lookups, you have a lot of information you can use to verify that the token, access token, in this case for the API request, is valid or not. And that's one of the strengths of JSON Web Tokens. If you want to know more, there's this website that we've created and we maintain, just as a full disclosure, it's made by us, but it's free to use by anybody, in which you can debug your JSON Web Tokens. If you paste it in here, we don't send your tokens somewhere to a backend, or we don't save them. It's all anonymously done in the front end. So it has this debugger, but it also has a list of libraries in a lot of different languages, so you can use it with a lot of different languages and frameworks. And we're at a PHP conference, so There's a bunch of different libraries you can use for PHP. They help you to work with JSON Web Tokens more easily. If you want to know more, jsonwebtoken.io, jwt.io. So, are there some downsides to JSON Web Tokens? Because every good thing also has a downside, right? And there might be a few. The most important one is invalidation of web tokens is a bit harder, because a JSON Web Token contains all the information of its validity inside of this token. Once it has been issued, you cannot change this token anymore. So if you want to revoke a token for a certain reason, let's say today my colleague Ben started working at Auth0 and he gets access to his email and to all our other systems. So we issue him a JSON Web Token which is valid for the rest of the day. But during lunch he says a remark to them like, I don't really like you, so can you please go home and you're fired? He still has his JSON Web Token somewhere in his browser maybe, so technically he still has access to our systems even though I fired him. So I want to be able to revoke this JSON Web Tokens which technically are valid in a certain way that he cannot use them after I decided I don't want them anymore. And this is often done by a blacklist or a whitelist. So after you've checked the validity of a JSON Web Token, you're also going to check it against a blacklist or a whitelist, just because you cannot change an issued JSON Web Token. So it makes it a bit harder, but not impossible. And of course, if you leak your secrets or private keys, you're going to have a headache, because they're called secret and private keys for a reason, right? So keep them secret. And again, don't put sensitive data in your JSON Web Token. It's just base64 JSON. Everybody can go to base64generator.com, paste it in there, and see the contents of this base64 encoded JSON object. So be aware that it's just public data, unless you encrypt it, but most people don't do this. So we've seen what a token is. We've seen traditional authentication. Let's look a bit at token-based authentication. Same scenario, user, browser, server, API, whatever you want to call it. We do a request until we hit a protected resource. We have to authenticate. We pass our credentials, username, password, or whatever, to the API. And if they match, we get back our data. But instead of a cookie, we also get back an access token. We've seen this in practice before. We save this access token somewhere in memory. And every time we want to access a protected resource from this point onwards, we just send this access token instead of our credentials again and again and again to access this protected resource. And if it matches out, you get your data back. You can do this in JavaScript very simple like this. The most important part, doesn't matter, is that you send your authorization header with the bearer token, which is your JSON Web Token. In PHP, it's the same. In every language, it's the same. You just send the authorization header with every request that needs the authorization happening. So, OAuth. Who's ever used or heard of OAuth before? Almost everybody. Cool. OAuth 2.0 is a protocol that allows the user to grant limited access to their resources. So OAuth is meant to grant limited access. It has nothing to do with authentication and identity. But most people misuse OAuth to do authentication just because you can if you want to, but it's not meant for this. If you want to do authentication with a token-based approach, you're often going to use something like OpenID Connect. Now, who has worked with OpenID Connect before? I see a few more hands. Well, I think that most of you do like a bastardization of OAuth and OpenID Connect without realizing it. And OpenID Connect was created as an identity layer on top of OAuth 2.0. So if you take OAuth 2.0, the latest version of OAuth, and you add an identity layer on top of it, you have OpenID Connect. And this is basically the ID token we saw before, which contains the information about the identity of the person authenticating. So if you want to do a token-based approach to identity and authentication, take a look at OpenID Connect and don't misuse the OAuth spec, even though it's possible. So again, more or less the same example, but now we split up our authorization server and the rest of our APIs to make it a bit more clear. We send our credentials to our authorization server, or we enter them on our authorization server. If they match up, we get our access token back. But we don't only get your access token back, you can also get your ID token back. And if you really want to, you can get your refresh token back, even though that's not always a good idea. We save those somewhere in memory, and every time we need access to a protected resource, we send that access token to our API, and if it matches out, we get our data back. But I just mentioned that we save these tokens in memory. You should never ever save them somewhere persistently, because they're vulnerable to XSS attacks, cross-site scripting, because who uses NPM or Composer package management thingies to pull in some external code that you didn't write, but it's easy to use? I think I want to see all hands go up. Now, who looks inside of these packages to see what the code really looks like or what it really does? And I think that I can see all the hands go down, right? We like to use code from other people because it's easy and convenient, but we don't look inside of these packages because we trust the people who write them, that they write what they say they're writing. But there could be some code in there that just goes through all of your cookies or through all of your local storage and steals everything inside of there and sends it to a server somewhere. And that's how your tokens can be stolen as well. So you're more or less always vulnerable to XSS and cross-site scripting. So don't save your tokens somewhere persistently. Does this mean that the user has to log in with every visit? Luckily, no, it does not mean that. The login flow remains the same. So we send our credentials, and if they match out, we get our tokens back, access token, ID token, and maybe a refresh token. But together with this, we also get a session cookie back. So we're back to session cookies again. We save these tokens in memory, and this cookie gets saved by the browser somewhere. And with each next visit, the request token, or we request the tokens again and again and again. This means that if the user visits your website or refreshes, we send this cookie in the backend, in the background, as a silent request, often in an iframe, to our authorization server. And if it matches out, if the session is still valid, we get our tokens back and we can send them to our single-page application. So we request the tokens every time the user visits our website in the background as a silent request. This means we can save them in memory instead of saving them somewhere persistently. And if you want to use your tokens, you can use them like you want to. Now, this is the OAuth implicit flow, and recently, I think in December, the IETF issued a best practices document stating that you should not use the implicit flow anymore if you start a new project. This doesn't mean that you have to start rewriting all of your projects which use the implicit flow, because you probably have mitigated most of the risk inherently connected to this flow. But if you start a new project, it might be worth looking into the authorization code with proof key for code exchange, PKCE in short flow, which is a bit more complicated, but a bit safer as well. It looks a bit like this. You go do your authentication requests or credentials using a password, but together with your credentials, you also have a code challenge. You send this to your authorization server, and the authorization server remembers this code challenge. It will not send back your tokens immediately. It will send back a code, a challenge. And you're going to take this code in your client, and you're going to sign this, verify this. And then you send that code together with a code verifier back to your authorization server. And based on this code, you send them in the initial request, and the signed challenge you send in the second request. It can verify that the process of requesting your tokens, your authentication process has been initialized by the same client, because this code verifier and initial code challenge. And if all of that matches out, you get your tokens back. So you have two more steps, but it's a bit more secure than the implicit flow, and it solves some of the issues that the implicit flow has that are known to people who are very knowledgeable about implicit flow, so security experts and stuff like this. A note about access tokens as JSON Web Tokens, because I've just mentioned that you can use them as JSON Web Tokens. The OAuth spec does not specify what an access token should be, so you can use any format you want, including JSON Web Tokens. But one of our colleagues, Vittorio Bertocci, has written a spec that specifies how a JSON Web Token access token should look like, and it's been accepted by the IETF as a draft and might become a standard. And that looks a bit like this. So this is the whole document which describes how it should look like. And the most important part, this is an example of how an access token can look like in the form of a JSON Web Token, which is more or less the same as I showed you before. But as a type, we have access token plus JSON Web Token, just to make it a bit more standardized. So ID tokens, I just mentioned that access tokens are not specified in the spec how you should create them, what they should be. They can be UUID, they can be a JSON Web Token, they can be anything. An ID token is always going to be a JSON Web Token that's specified in the OpenID Connect spec. So access token, whatever you want. ID token, always a JSON Web Token. And then a little note about refresh tokens, because a lot of people use them together with single-page applications. Using refresh tokens in the front end should be avoided unless a system of refresh token rotation or standard constraint is in place. So unless you rotate your refresh tokens on a regular basis, you can use them in the front end. They're less prone to, when they get stolen, they might have been rotated again by the time the attacker wants to use them, so it's a bit more secure. Or if you can use standard constraint, which isn't possible, it's only a theoretical process that's been going on to find a way to do standard constraints in the browser, but there's no practical way of doing this yet. So unless you have refresh token rotation in place, you should try to avoid using refresh tokens in the front end with a single page application, and do something like a silent request in the background to get new tokens instead. So, does this approach solve for CORS? Who thinks it does? Nobody thinks it does. With the silent authentication. So you send this cookie from your authorization server, it gets saved by the browser, and every time you bootstrap your single-page application, you do a request in the background to get, with this cookie, if it's still valid, you get your tokens back, and you have the tokens you need, so the user stays logged in like this. Technically, it's logged out for the first second or whatever, milliseconds, but as soon as this silent request resolves, you get your tokens, and you are logged in again. It does. It does solve CORS, because as long as you know the public key to verify the token, as long as you know the shared secret to verify the token, and as long as you can decode base64, which we all can, you can verify that a JSON Web Token is valid, right? A JSON Web Token is not issued to a certain domain, a certain origin. It's just a token that lives on itself, contains all of its information inside of it. So as long as you know how to verify this token, you can use this on any origin, on any domain you want. So it does solve CORS, because a cookie is linked to an origin, a token is not. Does that make sense? Yes, maybe. Let's say yes for now. Does this approach solve flow? So can you pass tokens from one origin, one domain to the others? Who thinks it does? See some hands going up? And it does, because as long as you know how to verify the token, you can pass it along to anybody that you want to, even though you usually specify an audience in the token, so it can be used by a certain API or certain APIs, because it can also be an array. But as long as the origins or the domains or the services are inside of that audience, and they know how to verify these JSON Web Tokens, you can pass them along from one to the other if you want to. It's not always the best practice, but you can do this if you want to. And lastly, does this approach solve for keeping state? Who thinks it does? No hands? And in theory, it does, because the token contains all of the information, but because we want to do things like silent authentication, in which we have to keep a list of session cookies again, or session IDs, or if you want to keep a blacklist or a whitelist to invalidate tokens, you're back to state. So in theory it does, but in practice most of the time you still end up with a bit of state, unfortunately. But nothing to do about that for now. So we have a bit more time, so let's look a little bit at the future of authentication, because we've talked about how modern apps use a token-based way of authenticating and getting access to protected resources. But we can also look a bit about the future. And the weakest link of authentication at the moment is users, and users who have to remember passwords, who uses a password manager. That's quite a lot. That's really nice. If you don't use a password manager, try it out. It might change your life. But a lot of time, people who are not in tech definitely have one password which they use for every website, every service, every app. And if this gets stolen, you can get into some problem. There's this new API called the Web Authentication API, or Web Authent for short. If you want to Google some more information, it's better to Google Web Authent than Web Authentication API. It's a bit long. But what this is a private public key-based authentication on the web. This means maybe in the future there's no more passwords. And you might be saying like, oh, we've passwordless for a long time. If I want to log into Slack, I just request a magic link, and I just click on this link. I don't have to enter my password again and again and again. And that's true, but when you initially registered to most of these services, you still had to create an account with a username and a password, or email and a password. So it's your initial registration process still involves a password most of the times, and then after that you can do some passwordless authentication. While with this approach, you just register with a public or private key pair, some information that's derived from the or signed by the private key instead of a password. And it's logging in with an authenticator device. And I have one here. It's just a little USB drive. All my keys, you cannot see this in the back, but you know what a USB drive looks like. And it looks a bit like this. The user wants to register on a website, or it wants to access a protected resource, so it has to register first. So that authorization server sends back a challenge. This is a random unsigned integer array, whatever you want, something random that it sends back to the browser. The browser sends this to your authentication device, this little USB drive. And this drive contains a private key, which is going to use that key to sign this challenge. Once it signs this challenge, it's going to send back this signed challenge together with the challenge and some public key information to your authorization server, which you'll save for future authentication requests. And looks a bit like this. Let me first plug in my little key. If I click on this button, I'm going to get a random challenge, and it's going to be passed along by the browser to this authentication device. Chrome already figured out that I have one plugged in. I have to touch it just as a security measure so that it cannot be plugged in and some website can do this in the background or whatever. And since I'm on localhost, I have to allow it. But when I do this, it's going to sign this challenge that I send back and send back some public key information. This is a raw ID of my public key. You get some other information if you decode this. But I just registered my authenticator device in the browser and got some information back from it. But then, who has an authenticator device? Almost nobody. Not that many people. And I tend to argue with this because who has a laptop or an iPhone or a mobile phone that's younger than, let's say, 5 years? I see everybody's hand go up. You can also say 10 years because it's been in these devices for a long time. Most modern devices have this little special chip in their chipset. It's the Apple A2 chip. Intel has its own version. Every device has a little chip that does nothing but authenticating, has a private key, and it keeps that very secure, and it can sign challenges, and does nothing else but this. So most modern devices have an authenticator device built inside of them. So again, the same demo. If I click on this, instead of using my USB drive, we're going to use the built-in one into my MacBook. Now, my MacBook has Touch ID, so I can lock this little chip with Touch ID, which is a nice extra feature. But if you don't have this, unlocking it with a password, which is back to passwords, but that's something else, should also be possible in the future. So I click on this. Chrome figured out that I have a Touch ID, so I touch it. And if it checks out, I get back the raw ID of my public key again. So I just registered credentials using my fingerprint instead of using a password, which is so much nicer. You don't have to remember your fingerprint because you have your fingerprint. And it's built into my MacBook. It's good to know that all browsers support this in one way or another. It's still a spec in process. I mean, the spec is finalized and accepted by the W3C, but the implementation in 2 browsers is still in progress. Chrome has the best implementation, but Firefox has one, Edge has one, especially now that it's going to Chromium, but also before. And Safari has an implementation in the tech preview behind the flag. So if you really want to use this in Safari, it's also possible, but only in the tech preview behind the flag and not on mobile. This means that you cannot do this on an iPhone. But if you run Android and you have Chrome on your Android, you can use your fingerprint scanner as well to do this on an Android phone. I'm sorry? The private key is on that little chip and it's secured on that so nobody can access this. You just pass along a challenge to it and it signs this and it sends back the challenge and the public key information. But I don't know how they manufacture this in detail, but I think they do this anonymously because it's always a different private key on those chipsets, right? It gets generated on the fly. So it should be, it's meant to be very secure. But the really implementation details of how they make this, I cannot give you. Sorry about that. So if you want to register a credential, there's 2 methods basically which this API exposes in the browser. The first one is to register one when you start using this API. It's navigator.credentials.create and you can give a config, basically some public key information. A challenge is, this is a challenge you're going to sign while registering your device. Some information about the relaying party, so the website that is sending you this challenge or wants to register your credentials. Some information about the user, if you want to. And then some information about the authenticator selection or the authenticator device. For instance, you can allow only built-in authenticator devices or only external ones. Or you can allow only authenticator devices that needs some user verification. So I need to touch my USB drive, for example. You also have some which don't require this. And you can not allow these if you want to, just to make it a bit more secure. And once you've registered your credentials, you can also use them again to authenticate in the future. It's navigator.credentials.get. Again, you give a config. It's public key information. A challenge, you always sign a challenge, and based on the signed challenge and the saved public key, you can verify that one comes from the other. And then you give the raw ID of the public key you used to register in the first place. You send it along as well. And then some more information about your authenticator device if you want to. And this is basically how it works. You just have two methods implemented in browsers, create and get, navigator.credentials.create and navigator.credentials.get. If you want to know more about this, webauthn.me, also created by us, but also just about the spec. And what this does is it has a little interactive tutorial which you can use. So if you want to register credentials, you see that it gets a challenge back for your authorization server. And when it lands at the authenticator device, you choose a way to authenticate. I choose my Touch ID. And it signs the challenge and sends back the signature with your public key information, and you save it on your authorization server. So we've registered this device. Next time you want to authenticate, you send along the raw ID of that previously generated thingy. And you do the same thing. You get a challenge from your authorization server, send it back to your authenticator device. You unlock it with Touch ID, which seems broken, but that's okay. I should be able to unlock this with my Touch ID, but it doesn't work for the moment. And you get back a raw ID and some signed challenge. It also contains some information how it works in detail, and since recently we also added a debugger, so you can play around with the config which you pass along to these two methods, the get and the create method, because the config is quite big, so you can change some things in here and then try it out on the fly, like the current config, and then signing stuff, and this is what you get back. So if you want to play more or learn more about the Web Authentication API, webauthn.me is where you can go to. So let's summarize. Using session cookies is hard with single-page applications, mostly because we consume a lot of different APIs with different origins, and our application might run on a different origin as well. So using cookies is a bit harder when you do stuff like this. Stateless authentication is possible, asterisk, because blacklist, whitelist, session cookies, which you do use for silent authentication. JSON Web Tokens consist out of three parts: the header, the payload, and the signature. And in the future, we can use WebAuthn to maybe get rid of passwords, which I hope it will. Maybe one more remark on WebAuthn. It's usable today, but it's only used as a second factor, just because browsers don't have the full implementation of the spec yet inside of the browser. But you can use it as a second factor on GitHub, Google, some of the bigger websites today. If you want to know more, JSONWebToken.io, webauthn.me. We have a good blog post about why the implicit flow in OAuth has been discouraged, and they advise you to use the PKCE flow instead. And our blog is full with other cool articles as well. If you want to see these slides again, jwt.sambaker.tech. I will tweet them again later as well, and I think the organization also has them, so they will send them to you if you want to. My colleague is talking tomorrow about why you shouldn't care about security. So if you're interested in this, tomorrow at noon in Martin A. And on Thursday, he's talking about opening doors with JSON Web Tokens, in which he will open a real door with a JSON Web Token. So if you're interested in this, Thursday at 14:15 in Martin, BC. Thank you.